Welcome back to Honors Topics in Physics. Today we're going to be doing a little bit of an algebra review, including solving equations, looking at the dependent versus independent variable, graphing, making the slope of a best fit line, and the y-intercept. To solve an equation for a variable, which could be x, it doesn't have to be x, it has to say x equals, and then that can be the only thing. So x equals b over 7 is solved for x. X equals 7 over b. X over 7 equals b is not solved for x, sorry. And 1 over x equals b is not solved for x. It has to say exactly x equal or a equal or f equals. The key thing when you solve an equation is you need to do the same thing to both sides. So if I have 7x equals b, I need the x to be by itself, so we divide both sides by 7. Cancel out the 7's, and we have x equals b over 7. So we divided both sides by 7. If you're going to solve an equation and you've got something that kind of looks a little fractiony, very often the best way to place to start is to cross multiply. So rewrite your equation so that they both look like fractions, and then cross multiply. So you get 1x equals b7. And that's always a safe thing to do, or x equals 7b, and that's solved for x, so we're done. Here we've got another one. We want to solve this for x. So the best thing to do, especially if what you're trying to look for, if the variable you're looking for is on the bottom of the fraction, I strongly suggest that you cross multiply. You don't have to, but it is the best way to do it. So cross multiply, and you'll get c times 4 equals b times x. So x times b equals c times 4. X times b equals c times 4. And we're not solved for x, so we need to get rid of that b. So we'll divide both sides by b, and we'll get x equals 4c over b. So now this equation, is this solved for x? X squared equals b over 7. No. If the variable you're looking for is squared, you need to do the inverse of squaring, and that is the square root, and take the square root of both sides, and you get x equals the root of b over 7. We're going to skip these. Remember that the independent variable is what the experimenter changes directly. It is the cause of the change. The dependent variable is what changes as a result. It is the effect of the change. So going back to that from before and applying it to what we're talking about today, we've got a scenario where the zookeeper keeps giving these monkeys more bananas each day, and she counts the number of monkey poops on the floor and kind of keeps track of that. So the independent variable, which is what is being changed directly, is the number of bananas. And the dependent variable, the effect of the change, is the number of poops. So we think if we feed more bananas, we're going to get more poops. So the cause effect. When you do a graph, the independent variable always goes on the x-axis. That is critical. And the dependent variable goes on the y-axis. So when I graph my data, my number of bananas is going to go on my x-axis, and the number of poops is going to go on the y-axis. The title should just be whatever the dependent variable is versus the independent variable. So for my example, it should be number of monkey poops versus number of bananas. So we'll, to kind of help you remember which goes where, you can think of the graph as a box, and the I, the independent variable, goes here, and the D, the dependent variable, goes here on the y-axis. So if that helps you, great. If not, don't worry about it. So, alright, so here we've graphed our data, number of bananas, independent variable on the bottom, dependent variable on the side, number of poops. Now when we've collected some data, one way of interpreting this data is through what's called a best fit line, and it's just either a straight or a curved line that goes through the data points and smooths them out. Because there's going to be error, experimental error, which is going to cause the data to be a little jumpy. Usually as opposed to a perfect line or a perfect curve, and what we want to do is use a line to kind of smooth that jumpiness out. So it can either be linear, where it just is a straight line, or it can be curved, where again we've got a smooth curved line. What we do not want to do is play connect the dots like the stock market. We do not do connect the dots. The best fit line, I mean, I don't really have a great way of telling you how to do it other than make it look good. It should fit the general trend of the points. And you know, I've heard that it should have about the same number of points above it and below it, and you know, that's an okay rule of thumb, but it doesn't have to be exact. So here we've got some data. Does this look like this would be a smooth curve, or does this look like this would be a straight line? You could kind of make a case for curve, but I think really it would be kind of a wonky curve. It's kind of going back and forth. So we're going to say that that's a straight line. This data right here, would that be linear, or would that be curved? That one would be curved. A nice smooth line would fit through that. Okay. Again, we're just kind of jumping through a bunch of stuff reviewing from middle school math. Slope. Rise over run. So the vertical, the delta y over the delta x, the run. So in this case, 4 centimeters rise divided by 8 centimeters run. What should the unit be on my answer? If you said no units, you are correct. So here we've got a slope of 0.5. The steeper the slope, the bigger the slope number. So here I've got a rise of 6 and a run of 4, so my slope is 1.5. So positive slope slopes up and to the right. Negative slope slopes down and to the right. When you calculate the slope of a line of best fit, and we're going to be using the line, not the data points, do not count blocks. Okay? You need to read the graph itself and calculate the rise and the run that way, and I'll show you what I mean by that. So here we've got some data, and we're going to do a best fit line. Would this look like it would be curved or a straight line? Looks like it should be probably a straight line. So we've got, you know, some data points above it. Got some data points above it. We fit the basic trend of it. Okay. Now, what is the independent variable in this experiment? The independent variable goes down on the x-axis here. It is the number of donuts eaten. Okay, and then the weight gained in kilograms goes on the y-axis. Note if you've got a unit, you should also label that on your axis in parentheses. And here we've got dependent variable versus independent variable for the title. When you select your points for the best fit line, don't choose points that are too close together. That'll introduce some error. You want to try to get points that are further apart, and also that ideally land at an intersection. So here it looks like it crosses this grid intersection right here. So I'm going to choose these points. They're far apart. Okay. Oh, and look, I changed them on the next slide. Just go with it. When you choose your points, and I want to highlight here, we're not choosing data points. Okay, we're finding the slope of the best fit line. If you happen to have a data point that's on the best fit line, you know, you can use that. But we're finding the slope of the best fit line, not the data, 2 data points. Okay, so when you calculate the slope, what I want you to do is to put a triangle around the points that you're going to be using to calculate your slope. Okay, so I've got a triangle here and I've got a triangle here. So use dots to plot the data, and then use triangles to represent the 2 points that you're going to use to calculate your slope. That makes it a lot easier for me to grade and therefore give you partial credit or credit for. So please do that. So next we're going to calculate the rise and the run. Okay. The rise, okay, is from, we're at 100 and we go to 450. So the rise is 450 minus 100 divided by, or I'm sorry, minus 100, it equals 350 kilograms. Don't forget units. And the run is going to equal 65 minus 5 equals 60 donuts. So that's a rise and a run. To calculate the slope, we put the rise over the run. 350 kilograms divided by 60 donuts, and we get 5.833. And there is something wrong with my answer. It is missing something. That is the unit. And what should the unit on the answer be? Kilograms per donut. It should be 5.8 kilograms per donut. Now you should always check to make sure your slope has got the right sign. Should my slope be positive or negative in this case? Okay. It should be positive. And if you plugged in y2 minus y1 divided by x2 minus x1, you know, the slope formula like from math, then you would have gotten the right sign no matter what, assuming you did it correctly. Okay, so our m, remember y equals mx plus b. Our m is equal to 5.8 kilograms per donut. That's our slope that we just calculated. To find the b, okay, I'm going to make this easier for you. You do not have to plug a point back in into your slope equation and solve for b. All you have to do in this class to figure out b is read it right off the graph. It's the y-intercept. It's where the line intercepts the y-axis. So that looks like it would be about 60 or 70 kilograms would be what I get it as. So I put it as 70. So and then you're done. Okay. So what I want you to do is do the first two sides of this worksheet 1.4. That's this side and this side with the graph. It would be ideal if you could print this out. If not, then just do the best you can. So number one, number it, and then solve the equation for these variables. This one might be a little tricky to do. This one I'm not sure how you would do unless you can print it out. Number two, match the slopes. Just write the answers as far as which one goes where. This is also going to be a little tricky unless you print out the worksheet. If you can't print it out for whatever reason, just do the best you can and show work for calculating the slope. Show me the work for calculating the slope, and just, yeah, like I said, do the best you can. And write the equation in y equals mx plus b format. So figure out the slope, calculate it, and the y-intercept, just read it off the graph. And you can just stop right there.